Welcome to the Explainer. So if you're building applications on Kubernetes, you've definitely run into this critical question: where do I put my configuration? Today, we're diving deep into ConfigMaps. They're the Kubernetes native way to decouple your code from its environment, which is the key to making your apps portable, scalable, and, truly cloud-ready. Okay, so here's our game plan for today. We're going to start by really framing the problem that ConfigMaps were built to solve in the first place. Then we'll look at how they fit into that bigger cloud-native philosophy. After that, we'll get our hands dirty with creating and using them. We'll tackle the very tricky puzzle of updates, and then we'll wrap up with some hard and fast rules for using these in production. So to really get why ConfigMaps are even a thing, we need to rewind the clock a little bit. We've got to look at the problem they were designed to fix, which all comes down to something called configuration drift, and just a massive shift in how we think about infrastructure. Yeah, we used to treat servers like pets. You'd give them a cute name, you'd carefully maintain them, you'd log in and tweak files by hand. But that always led to configuration drift, where no two servers were ever really the same. The whole cloud-native approach, well, it treats them like cattle. They're identical, they're replaceable, and they're managed as a herd. In this new world, baking your configuration right into your container image isn't just a bad habit. It's a critical design flaw that basically breaks the entire model. Okay, so if baking config into your image is the big no-no, what's the solution? Well, it's not just about some single tool. It's really a core philosophy for building modern software. And it all starts with a pretty simple but actually profound idea. This question right here. This is the heart of what's called the 12-factor app methodology. Just think about it for a second. Could you make your code public on GitHub right now without leaking a single secret? If the answer is no, it means sensitive stuff like API keys or database URLs are all tangled up in your code, and that is exactly the problem that externalized configuration is designed to solve. And that brings us right to a core Kubernetes principle. Configuration isn't a script you run or some template you have to process. It's just data. That's it. Kubernetes treats it as a first-class object, basically a dictionary of key value pairs that lives inside the cluster's brain, ready to be delivered to your application the moment it starts up. Okay, so we've established that config is just data living in the cluster. But how do we actually create it? And how does our app get its hands on it? This is where we run into a few really key decisions that every single developer has to make. When it comes to creation, you've really got two main paths. The first is the imperative way, which is great for development. You can just create a config map on the fly, right from the command line, using a value or a local file. But for production, the declarative approach is absolutely king. This is where you define your config map in a YAML file, often using tools that automatically generate a new, versioned map anytime the source content changes. This is totally essential for any kind of automated, reliable deployment pipeline. So, once the config map is living in your cluster, you hit the most critical fork in the road. How is your app actually going to get that data? Is it going to be through environment variables or as files and amount of volume? The answer you pick has huge consequences, especially when it comes to how you handle updates down the line. Let's just break down these trade-offs because they're super important. Environment variables are perfect for simple values, a database URL, a feature flag, and they fit perfectly with that 12-factor app design. But their single most defining characteristic is that they are static. They get set when the pod starts, and they will never, ever change. Volumes, on the other hand, are the total opposite. They're designed for whole files, like a big, complex nginx.com file. And, crucially, they are dynamic. If you update the config map, the file inside the pod eventually gets updated too, which allows for cool things like hot reloading your config. Okay, let's dig into that word dynamic, because this is honestly a huge source of confusion for so many people. Just because you're using a volume mount doesn't mean your app is going to magically see changes the second you hit apply. There are some really serious gotchas. And the biggest gotcha of them all, it actually has a name: the subpath trap. And trust me, if you've been working with Kubernetes for any length of time, there is a very good chance you have fallen right into it. So here's how the trap works. You just want to mount a single file from your config map, not the whole thing, so you use subpath. Seems totally logical, right? But it's a trap. What subpath is doing under the hood is it's locking your pod to the specific version of that file that existed when it first started. So Kubernetes will update the data in the config map, but your pod, it's completely blind to it. The update will never arrive until you restart that pod, which totally defeats the whole purpose of using dynamic volumes in the first place. So if dynamic updates are basically out, How do you reliably roll out a config change? Well, you have to force a pod restart. The two most popular ways to do this are either the Helm checksum pattern, where you inject a hash of your config map right into the pod's template, so when the hash changes, it triggers a rolling update. Or you can use a controller like Reloader, which automates this whole dance for you by just watching your config maps and triggering the rollout automatically. All right, let's wrap this all up with some absolute non-negotiable rules for using config maps safely and effectively when you go to production. Rule number 1, know the size limit. A config map cannot be bigger than 1 megabyte. Now, this isn't some arbitrary number. It's because all of this data is stored in etcd, which is kind of like the central brain of the entire Kubernetes cluster. And etcd is optimized for small, super fast transactions, not for being a file storage system. And now for what is probably the single most important rule. Config maps are for non-confidential data only. If what you're storing is a password, a token, or a certificate, it belongs in a Kubernetes secret. Period. Secrets are just built differently. They can be mounted in memory instead of on disk, and their values are hidden when you run kube control. Think of this as a hard security line that you just never, ever cross. And one final critical security myth that we have to bust. Base 64 encoding is not encryption. All it does is make sure the data doesn't get garbled. By default, the data inside both config maps and secrets is stored as plain text inside etcd. To truly secure it, your cluster admin has to enable something called encryption at rest, which actually encrypts the etcd database itself. So, to wrap it all up, config maps are way more than just another Kubernetes feature. They really represent a whole mindset shift. They force us to ask the really hard question you see on the screen: is our configuration truly decoupled, or have we just kind of hidden it in another file? Getting this right is absolutely fundamental to building modern, scalable, cloud-native applications. Thanks for joining this explainer.